All right, geometry, today we're just going to have a real short video looking at a couple concepts of what makes chords congruent and then how that also makes the arcs that they create congruent. Okay, so let's go ahead and get some theorems in here first. So two chords are congruent if and only if. So that means that this statement goes both ways. So two chords are congruent if and only if their corresponding arcs are congruent, if I could spell. So what does this mean? This means that AB is equal to CD. So we're talking distance here. The length of AB is equal to the length of CD if and only if the measure of arc AB is equal to the measure of arc CD. And Cami doesn't have an arc tool, so let me just get that on there real quick. So the measure of arc AB is equivalent to the measure of arc CD. So if these two line segments are congruent, if they have equal distances, AB and CD, then these two arcs are congruent. So arc AB and arc CD here, meaning that they have the same degree measure. They also have the same arc length because they're in the same circle. Okay, the other thing that we're going to look at is that two chords are also congruent if and only if they are equidistant from the center of the circle. So if two chords are exactly the same distance away from the center of the same circle, then they have to be congruent chords. So in more symbolic terms here, that means that if AB is equal to CD, then EF is equal to EG. So remember that we measure distance at a perpendicular angle, so a right angle. So if AB is equal to CD, then that means that EF here is going to be equal to EG, and vice versa. If we're given that EF is equal to EG, then we're also given that AB is equal to CD. Okay, so those are a couple concepts, a couple theorems that we will prove in class that show that two chords are congruent. We also have something else interesting happening here with these right angles. So if a diameter or a radius, so some line segment going through the center of the circle, is perpendicular to a chord, then it bisects the chord and its arc. So if we look here, bisects the chord and its arc. So if we look here, we've got this radius, EH here, is perpendicular to AB. So what that means is that AF is equivalent to FB, and also arc AH is equivalent to arc BH. Those are all congruent. So we can say that, let's see, let me get my segment symbol out here. So we can say that if segment EH is perpendicular so segment EH is perpendicular to AB. Oops, it's been a while since I used that segment tool. Then that implies that the distances AF is equal to AB, and it also implies that the measure of arc AH is equal to the measure of arc HB. So let's look at that one more time here. Let me get my arc symbols on here. So if EH and AB are perpendicular, so they meet at a right angle, then that means that AF is equivalent to, I screwed that up, AF should be equivalent to FB. That was my bad. So AF is equivalent to FB, and also AH is equivalent to HB. These are congruent arcs. So what does that mean as far as problems are concerned? It means a lot of times we're setting things equal to each other. So basically all these problems here, 1 through 4, you are setting these numbers equal to each other. We'll get a little bit more complex than that, but we'll look at some examples of that in class. We'll prove these theorems. These are actually fairly simple to prove. In fact, I want you to think about how to do that, using triangles and maybe drawing in some more radii. You can prove these pretty easily. So we'll look at that at class. We'll do some example problems, and I'll see you then.